Okay, so this is the particle problem. A particle moves along the x-axis with velocity at time t greater than or equal to 0 given by this. So where this right here is our velocity. Okay. Our first job is to find the acceleration of the particle at time t equals 3. Okay. Acceleration is the derivative of velocity. So here's our velocity. We need the derivative of that. So the derivative of the velocity is the acceleration, and the derivative of -1 and 0, the derivative of e to anything is e to that thing times chain rule, the derivative of what's up here, which is -1, which means our acceleration is negative e to the 1 minus t. Okay, this is our acceleration. We want to know the acceleration when time t equals 3. So I'm going to plug in 3 for t, and I'm going to get negative e to the 1 minus 3 equals negative e to the negative 2 equals, if you would like to, that's the answer, or you could rewrite it as negative 1 over e squared. Either of these two would be fine. That's the acceleration. Okay, so B. Is the speed of the particle increasing at time t equals 3? So what we need to know to figure out whether the speed is increasing or decreasing is whether the velocity is positive or negative and the acceleration is positive or negative. Remember, if the signs are the same, the speed is increasing. If the signs are different, then the speed is decreasing. So at t equals 3, the acceleration is this, which is negative. So now we just need to figure out whether the velocity is positive or negative. So the velocity, which is right here at 3, is, I plug in 3 plus minus 3 equals negative 1 plus e to the negative 2, which is really negative 1 plus 1 over e squared. So think about that for a second. E is like almost 3. So this is sort of like a ninth. Negative 1 plus a ninth would be negative. So the velocity is negative. The acceleration is negative. So if the signs are the same, the speed is increasing. So you would say speed is increasing at t equals 3. And here's your reason. Because the velocity and acceleration, that's this acceleration, have the same sign. So there you go, that's B. Now let's have a look at C. Find the values of t at which the particle changes direction. Okay, so a particle is going to change direction when the velocity switches from positive to negative, or vice versa. So remember, the velocity can only change signs when it's 0, right? From positive to negative or negative to positive, it can only change signs when it's 0. So our job is to figure out when is the velocity 0. So that's the velocity. So when is that thing equal to 0? So negative 1 plus e to the 1 minus t, we want to know when that equals 0. So we just need to solve. I'm going to add 1 to both sides. This is a math analysis move you should know. Take the natural log of both sides. You get 1 minus t equals the natural log of 1. I've said this a bunch of times in class. You absolutely need to know that the natural log of 1 is 0. So this is 1 minus t equals 0. So 1 equals t. T equals 1. Okay. So you're probably going to be tempted to say, it changes directions once. It changes when time equals 1. Probably true, but we have to check. So what I'm going to say is maybe the particle changes signs when t equals 1. I'm going to make a little chart though. Okay, so if I want to know whether the velocity is positive or negative, I'm going to plug some things into the velocity. So the velocity, again, is this thing right here. Okay, so I'm going to plug some stuff in. If I plug in 1/2 to this, I get negative 1 plus e to the 1/2. E to the 1/2, square root of e. E is about 3, so, whatever, 1.6, 1.7, or something like that. That's totally going to be positive. I'm going to plug something else in here. Let's plug in like 20. This becomes negative 1 plus e to the negative 19. Otherwise known as negative 1 plus 1 over e to the 20th. You can see that this is really, really small. So this is negative. So that's negative right there. So the value at which t changes direction is t equals 1. And when it says justify your answer, I'm not going to write it, but what you would write is t equals 1 is the only time when the sign of the velocity changes. And that's the whole thing.